underneath that, there's no oxygen, no life. And down there we found conchs and conch shells and hermit crabs that had fallen into the hole and suffocated.
60 meters down inside Belize's Great Blue Hole, the lights from the dive team cut through black water that feels almost solid. What should have been a peaceful descent turns heavier the closer they get to the seabed, where oxygen disappears and silence takes over completely. And when they finally reach the bottom, it is not just sand waiting there, but a record of storms, decay, and time locked away for thousands of years. And it gets worse. The place that became a legend before the dive. 60 miles off the coast of Belize, the ocean suddenly changes color, like someone dropped ink into clear glass. That perfect circle of deep blue you see from the air is the Great Blue Hole, and before anyone even thinks about diving into it, the place already feels unreal. Boats drift above it like they've reached the edge of something unfinished, something the ocean never bothered to close. And here's the thing. Long before the 2018 expedition ever showed up, this hole was already famous, not because of what people had seen inside it, but because of Jacques Cousteau, the legendary explorer who called it one of the most remarkable underwater formations on Earth after studying it in the 1970s. We tend to think of places like this as natural wonders, almost like they exist just for tourism or drone footage, but the truth is more layered. According to a 2018 announcement from Aquatica Submarines, published via PR Newswire, the Great Blue Hole expedition wasn't some casual dive. It was a carefully planned scientific mission designed to map the sinkhole's full depth, collect sediment samples, and understand how the environment at the bottom actually behaves under extreme conditions. And get this, they weren't going in blind. Previous sonar surveys had already suggested something unusual at the base, a flat, almost sealed layer that hinted at very low oxygen levels, something that would make survival for most marine life nearly impossible. Weirdly enough, that scientific seriousness sits right on top of a kind of pop culture fame. The Blue Hole is one of those rare places you've probably seen even if you've never been to Belize. Featured in travel magazines, aerial drone videos, and ocean documentaries for decades. Jacques Cousteau's early exploration in the 1970s gave it credibility, but what really pushed it into global awareness was how perfectly it was photographed from above. A near-perfect circle in the Caribbean Sea, almost too clean to feel natural. According to coverage from Live Science, that visual symmetry is exactly what made it a target for deeper exploration, because scientists weren't just interested in beauty, they wanted to understand how something so geometrically perfect formed in the first place. But here's where it stops being just a pretty satellite image and starts becoming a real question about human curiosity. Why does a place like this pull so many expeditions, so many billionaires, so many scientists willing to spend years preparing for a single descent? According to a 2019 Forbes report by Priya Shukla, the 2018 expedition brought together figures like Richard Branson and Fabien Cousteau, along with Aquatica Submarines, all focused on one thing: getting a complete picture of what lies at the bottom. Not just depth, but chemistry, sediment layers, and long-term environmental records locked beneath the sea floor. And think about that for a second, because most people see a dive like this as adventure, but for them, it was data collection in one of the most extreme, low-oxygen environments on Earth. By the time the submersibles reached the Blue Hole in late 2018, according to coverage from SlashGear, the mission had already shifted from curiosity to precision work, mapping every contour of the sinkhole floor with sonar, collecting sediment cores that could reveal centuries of climate history, and documenting oxygen levels that dropped to almost nothing near the base. It wasn't just about seeing the bottom anymore. It was about reading it like a geological archive waiting to speak. Once the expedition entered the deeper Blue Hole, the ocean stopped feeling like open water. Light faded in ways the team didn't expect, and the water began to feel layered and structured. According to expedition notes referenced in Live Science coverage, this moment marked the shift from exploration into uncertainty, as everything they thought they understood about about the seafloor environment started to break down, and the mission's confidence disappeared beneath pressure. What was this realm the scientist had stumbled upon? The toxic line, where the ocean stops behaving like ocean. Around 300 feet down, everything changes so abruptly it almost feels like the water itself hits a wall. One moment you're still in familiar blue Caribbean water, the next you're pushing into something heavier, darker, and strangely still, like the ocean forgot how to move. And right there, according to expedition reports later covered by Live Science, the team encountered a hydrogen sulfide layer, a kind of invisible chemical boundary where oxygen drops to near zero and normal marine life just stops existing. But the real shock wasn't just the chemistry, it was what existed below it. Now here's where it gets unsettling. That layer isn't just a marker, it's a cutoff. Above it, you still get drifting fish, light, and motion. Below it, nothing survives in any normal sense. According to Southern Fried Science's dive logs by Erica Bergman from the 2018 expedition team, the submersibles described it almost like entering a sealed room, except it's underwater and miles wide. The water shifts visually too, slightly hazy, almost syrupy, and for a second, you realize this isn't just deep ocean anymore. It's a chemically locked system that refuses life. Once the submersibles pushed past that toxic layer, the seabed came into view, and instead of a thriving ecosystem you'd expect from ocean depth, there was silence. Absolute, unsettling silence. Live Science's coverage of the 2018 findings described scattered remains of marine life, mostly dead mollusks preserved in the sediment, their shells sitting intact like time had simply stopped for them. No scavengers, no movement, just objects preserved in place because nothing down there can really consume or disturb them. And get this, that hydrogen sulfide boundary is not random. It forms because organic material sinking from above gets trapped in a low circulation zone, decomposes, and releases toxic gases that sit in layers. No oxygen mixing in, no flushing currents, just stagnation that builds for centuries. Gear's breakdown of the expedition describes it as one of the clearest examples of an anoxic environment in the Caribbean, basically a dead zone that has been stable long enough to shape its own chemistry entirely. And then there were the formations, mineral crusts growing in strange patterns across the floor, almost like frozen ripples. According to the New York Post's 2019 reporting on the expedition's observations, the seabed also showed long, linear tracks etched into the sediment. At first glance, they looked like movement trails, but there was nothing alive down there large enough to make them. That's the part that makes you pause, because you're looking at evidence of motion in a place that should not allow motion at all. Somewhere in that same zone, expedition coverage also noted debris and irregular objects resting on the bottom, fragments that didn't belong to natural processes alone. Gear referenced how the team documented human-related material among the sediment layers, remnants likely carried down over decades by currents or storms. And yes, according to multiple expedition summaries, there were even mentions of human remains recovered from earlier dives in the broader Blue Hole area, though preserved in such a way that they had become part of the geological story rather than anything recent or active. And think about that for a second. A place that looks like an open window from above is actually a sealed archive underneath. Everything that enters doesn't really leave. It just settles, gets trapped, and becomes part of the record. Here's the part that really sticks with you. If you dropped into the Blue Hole expecting an ocean floor full of movement and life, what you actually find is a kind of suspended stillness. Not empty, just locked, like the environment itself decided long ago that nothing new gets to rewrite the rules down there. It makes you wonder, doesn't it, how many other beautiful places on Earth are only beautiful because we never look closely enough beneath the surface. And once the team started realizing just how isolated this system really was, the question shifted, because the bottom wasn't just showing what had died there, it was quietly recording everything that had ever been forced into it. And that makes you ask, then what was the meaning of what they were exploring? The mud that remembers everything. They didn't find the big revelation where most people expected it. Not in the dramatic descent, not in the toxic layer, not even in the eerie seabed that looked frozen in time. It came later, almost quietly, when scientists pulled up something that looked completely unimpressive at first glance. Just a long cylinder of mud, about 30 meters deep, lifted from the floor of the Great Blue Hole. And yet, according to sediment analysis reported by physis.org in 2025, that core turned out to be one of the most detailed storm records ever recovered from the Caribbean. Layer by layer, it stretched back roughly 5,700 years, each band of sediment acting like a timestamp, preserving moments when hurricanes passed over and reshaped what was sinking into the sinkhole. It sounds almost too simple, but here's the thing. Nature doesn't need complexity to store memory. It just needs time. Now here's where it gets interesting. Every major storm leaves a signature. Strong winds stir up seabed material, runoff carries debris into the sinkhole, and those events settle into distinct layers, almost like pages in a book no one ever opened. According to Live Science's reporting on the 2025 study, researchers identified hundreds of these storm layers stacked on top of each other, some thin and faint, others thick and chaotic, marking periods when the Caribbean climate turned violent again and again. Think about that for a second. You're not looking at weather reports or satellite data. You're looking at ancient hurricanes preserved in silence long after every trace above them disappeared. And get this, when scientists compared the deeper layers to the more recent ones, a pattern started to form that was hard to ignore. The frequency of storm deposits in the upper sections, representing more recent centuries, begins to spike sharply compared to earlier periods. According to analysis highlighted by Science Alert, this suggests that tropical cyclone activity in the southwestern Caribbean has increased significantly in modern times, especially in the last few hundred years. That's where the tone of the discovery shifts completely. What started as a geological curiosity turns into something much heavier, because suddenly the blue hole isn't just recording history, it's showing acceleration. Here's the uncomfortable part nobody can really gloss over. The sediment doesn't argue, it doesn't speculate, it just records. And when you line up thousands of years of storm data inside a single vertical column, you're forced to confront the possibility that the climate system we think of as stable might not actually be stable at all. According to a broader interpretation shared in Love FM's coverage of the Belize study, the value of this core isn't just academic. It gives scientists a baseline, a way to compare modern hurricane activity against thousands of years of natural variation. And when that comparison is made, the recent spike stands out like a sudden break in rhythm. So here's a question that sits quietly underneath all of this. If a hole in the ocean floor can preserve 5,700 years of storm history without saying a word, should we still treat it like just another natural wonder? Or is it actually one of the most important climate archives we have? Because once you realize what's buried in that mud, it becomes impossible to look at it as just sediment again. And that leads into the real tension the expedition never fully escaped. If the blue hole can preserve this much truth about the past, then what else is it quietly recording right now, layer by layer, waiting for someone to read it correctly when the ocean starts warning you back? The numbers don't look dramatic at first glance, but that's usually how the most serious warnings show up. Somewhere inside the sediment record, pulled from the Great Blue Hole, the pattern isn't just about storms anymore, it's about speed, about change, about how something that once unfolded slowly over centuries has started tightening into decades, almost like the climate system is skipping steps it used to take its time with. And according to analysis summarized by Earth.com and phys.org in 2025, that 30-meter sediment core doesn't just show a history of hurricanes, it shows a rhythm shift. For thousands of years, storm layers appear spaced out, almost calm in their spacing, averaging only a few major storm events per century in the earlier sections of the record. Then you move upward through time, closer to the present, and the spacing starts collapsing. Layers stack faster, closer together, more frequently, like someone turned up the tempo on a song that was never meant to speed up. Now here's where it gets interesting. Scientists reviewing the upper sections of the core noted that recent centuries already show more storm deposits than earlier baseline periods. But what really stands out is the modern spike. According to Science Alert's coverage of the Belize findings, the most recent layers suggest a noticeable increase in storm frequency compared to the long-term average, something that doesn't fit neatly into the historical rhythm the Caribbean used to follow. Think about what that actually means in practical terms. This isn't just an abstract climate discussion sitting in a paper. It's the difference between coastal communities dealing with rare extreme storms spread far apart in time versus systems where recovery windows shrink before the next impact arrives. Infrastructure, agriculture, even migration patterns, everything gets pressured when the gap between events starts closing. And get this, when researchers cross-reference the sediment record with modern hurricane tracking data as reported by Live Science, the comparison wasn't subtle. The Natural Archive suggests that what we're seeing in recent decades isn't just variability inside a stable system. It looks more like a directional change, a shift away from the long-term baseline that held for thousands of years. Here's the part that quietly hits hardest. The blue hole isn't making predictions. It's not arguing theories. It's just preserving what already happened, layer by layer, storm by storm, without opinion or interpretation. And when that kind of record starts showing acceleration, it forces a very uncomfortable question about how we plan for the future, especially in regions like the Caribbean, where coastlines are already living on the edge of storm exposure. You start to realize something slightly unsettling here. We often treat natural history like background noise, interesting but distant. But what happens when that history becomes a direct mirror of current risk? One that's already reflecting changes in real time. It makes you wonder, honestly, if societies are reacting too slowly, not because the data isn't there, but because it's buried in places like this, locked in mud at the bottom of the ocean, where it doesn't scream, it just records. And once that idea settles in, the whole story of the blue hole stops being about exploration or even discovery. It becomes about interpretation, about whether we're actually reading the warnings correctly while they're still forming in real time beneath the water. Because if the ocean floor can clearly show a shift in storm behavior over thousands of years, then the real question isn't what it recorded in the past. It's what we're already sitting inside right now, without fully recognizing it yet. When the internet misses the real story. Scroll through the coverage of the Great Blue Hole, and you'll notice something almost immediately. The surface story is loud, mysterious tracks, creepy discoveries, scientists shocked, headlines that feel like they were built to make you stop mid-scroll rather than understand what actually happened down there. According to reporting compiled in LAD Bible's 2025 coverage of the expedition findings, much of the viral attention leaned heavily on dramatic interpretations of the seabed features, especially anything that looked unusual or unexplained at first glance. But here's the thing, the deeper scientific work never really disappears. It just gets quieter. Now, when you step back and look at the actual research trail, including analysis referenced in Unilad's expedition summaries and scientific breakdowns discussed by researchers like Erica Bergman's team logs, the story isn't about horror or mystery in the way the internet frames it. It's about a very structured environment, hydrogen sulfide layering, anoxic water behavior, sediment trapping, and most importantly, how a collapsed marine system preserves information over thousands of years without being disturbed. And get this, even the so-called strange tracks or eerie seabed visuals that made rounds online, as reported earlier by Newsweek's coverage of the Blue Hole, are far more likely linked to sediment movement patterns and underwater gas activity than anything cinematic. But those explanations don't travel as fast as a headline that feels like a mystery waiting for a twist. Here's where it gets interesting. The internet doesn't exactly lie about the Blue Hole, but it does flatten it. A chemically complex sinkhole becomes a viral clip. A 5,700-year storm archive becomes a footnote. And what gets lost in that translation is the part that actually changes how we understand the Caribbean, climate history, and even risk planning for coastal regions. Think about it for a second. If your only exposure to this site is short-form content or sensational summaries, you walk away remembering the creepy bottom or the dead zone discovery. But if you follow the research path, including sediment studies and peer-reviewed interpretations highlighted in phys.org's 2025 reporting, what you actually see is a natural climate archive that tracks hurricane behavior across millennia with uncomfortable clarity. So when competitors chase the most visually dramatic angle, they're not wrong about the facts. They're just pointing the spotlight at the least important part of the story. The real weight sits underneath all of that in layers of mud that record storms more honestly than any modern dataset ever could. And maybe that's the tension here. Viral science makes you feel like you've understood something in 30 seconds, but deep science takes time, and it rarely looks exciting at first glance. The blue hole doesn't reward speed, it rewards patience, the kind most online storytelling doesn't bother with. The blue hole stops being just a dive site the moment you realize it's been recording storms, chemistry, and death layers for thousands of years. The bottom showed a hostile world, but the sediment told the real story, a changing climate written in silence. Beautiful places like this aren't just scenery, they're archives. And once you see it that way, you don't look at the ocean the same again. Tell us what you think.